Hello my dear students, how are you all? Welcome to Deeksha Karnataka YouTube channel. I hope all of you are doing good. So I am here with another very high weighted chapter for your KCET examination from PU2 portions, integrals and AOI top 30. Okay, why club together? Because you can see applications of integrals are there. Okay, so why not club it together and do it at the same time and complete both the chapters? Okay, so of course I have taken quality questions in both the chapters, including PYQs, including other questions apart from the PYQs as well. Okay, so once you solve all these questions, you should certainly feel confident going into the examination, but make sure that you are comfortable solving all these questions. Okay, it's not like you're getting some resistance and the effort is taking a lot while solving these problems. Then you're not prepared completely. But if you can solve these problems effortlessly, means yes, you are right there with the preparation of this chapter. Okay, so let's start with the question number 1. So have a look. The value of this function, okay, integration is given. So you can see whenever you have e power x, means something will be there, some type of substitution will be used. So have a look. Okay, good for us actually, bacha, we have here e power x into x. Reason being, because if you check this out, e power x into x derivative, if you take, no, you're gonna get this as e power x x plus e power x 1. Okay, because you're going to differentiate e power x, keeping x as it is, and then keeping e power x as it is, and derivative of x is 1. So you can take here e power x common, you'll have x plus 1 over here. So you can check here, this part is there in the numerator. Okay, it means I can simply write this integration as dt upon cos square t, which will become sec square t dt. Hence answer will be tan t plus c. So tan of e power x x, tan of e power x x. What is the answer, bacha? Tan of e power x x. So I think option B is correct. Please check. Option B is correct. Replace t by e power x into x. Okay, so your substitution is going to be t equals to e power x dot x. That's your substitution. Moving on to question number 2 now. So we have the value of integration of this e power x times this extraction given over here, x square tan inverse of x plus tan inverse of x plus 1 upon x, or x square plus 1. Again, as I said, where if there is a e power x, means some property or some substitution will be there. Okay, so please check what can be used over here. You can see tan inverse of x is common in this, so we'll just take that out. We'll have integration of e power x x square plus 1 times of tan inverse of x plus 1 divided by, okay, the x square plus 1. That's a very simple question actually. Do one thing, separate this numerator with the help of this plus sign. You'll have e power x outside and you'll have this part, this. So please check, it will become simply this and this will cancel. You'll have tan inverse of x left here, and this part you'll have plus 1 upon x square plus 1 dx. This is f of x, and this is nothing but derivative of tan inverse of x. Okay, so basically answer will be what's e power x f of x plus c, hence e power x tan inverse of x plus c. Option A is correct. Option A is correct. Please check. Question number 2, option A is correct, and question number 1, option B was right. Okay, so here B, here A. Now before I move on to question number 3, I have a very important announcement to make for all of you. Make this sure that you are having test series with you right now. If you want to practice more and more questions regarding all the chapters in mathematics, in chemistry, in physics, in biology, you should be somebody who has taken the test series. Okay, so you have total 35 part tests and full length tests available in the test series across all the 4 subjects, which if you practice, there will be quality questions, very competitive questions. So because this exam is about solving problems, okay, and this is the last minute, you should solve more and more questions, more and more variety of problems, difficult level problems. So for that, and this test series is the must. Okay, one of the best test series available right now for KCET examination, uniquely made for KCET examination. The classification is there, easy, moderate, difficult. So we have made in such a way that you should be exam ready before the KCET examination. Okay, so make sure that somebody has purchased it at a price range of 1498. Okay, a lot of students have already enrolled to get into the competition. Be somebody who has this thing in their tool going to the examination. Okay, let's start question number 3 now. So we have the value of integration. Please check here, minus a to a. If it is odd, then 0. Sine power 103. Odd only, sir. Please check. If I write here sine minus x to the power 103. What will happen to this part? It will become minus sine x. We know the function or the property of sine. Power is 103 again. Odd power means it will become negative only. So minus sine 103x. So basically I'm starting from f of minus x and reaching here minus fx. Hence this part is odd. This part is even actually, but even into odd will be bacha odd only, na? The other part is actually even, sir. This is odd. Odd into even is odd again. Hence answer will be bacha. Please check. Minus pi by 4 into pi by 4, because bacha, this for this part only answer will become 0, right? So that's why answer is option D. Question number 3 answer is option D. Okay. So look, move on to question number 4 now. Question number 3 is done, right? Please check. Option D is right. Sometimes you have to remember the properties, okay? Especially in the case of definite integral, properties become very, very, very useful. You'll see in all the questions. So in definite integral, if you're looking at, know all the properties by heart, okay? As you can see the question, look at it, get that marks in less than 5 to 10 seconds. If you know the property, that's your answer, okay? Question number 4 now, the value of this integral, okay? I can see e and log means something will be cancelled. Let's check this out. So what I'm going to do is take these numbers on top of x. The coefficient of, for example, I'm saying this c6 log x is there now, so I'm going to make this like log of x power 6, okay? And of course there is an exponential function, so e is there. Keep here e and log will cancel the effect. You'll have simply x power 6 left, x power 6 left, okay? Same way you can go about this. Integration will become x power 6 minus x power 5 x power 4 minus x cube, right? Of course there is a dx over here, so we'll do one thing now. I'll take x power 5 common over here, x power 3 common in this side. So I have x power 5, I am leaving with x minus 1 in the numerator side. Denominator I have x cube common, so I get x minus 1 one more time, okay? Of course there's an integration over here, and we have dx as well. This is cancelled. I get x5 by x cube will become x square. Dx is the integration. So x cube by 3 plus c is the answer. X cube by 3 plus c is the answer, of course. Option B is correct. Please check. Option B is correct in the PYQ 2016 it was asked. Okay. So 4th is done. Moving on to question number 5 now. I hope you enjoyed the question number 4. Very simple, right? Okay. Question number 5. Again the property. As soon as I look at the question, no, I have the property of different integral. This one, bacha. Please check here. I can use this condition, no, pi by 2 plus 0 minus x. So basically pi by 2 minus x. This is for x. So wherever you have x in this integration, replace that by pi by 2 minus x. Okay. What will happen? You know the property. It will remain same. No, if I write this as I equals to this condition. So if I call this to be, let's say I equal to this part as my equation number 1. So I'll have same integral 0 to pi by 2, remember? And sine will become, at pi by 2 minus x, it will become cos. So cos power 1000 x dx. And this sine will become again one more time, as I said, cos power 1000 x plus cos will become so sine. Cos 90 minus theta is sine theta. So sine 1000 x, okay? Please check, this is my equation number 2. If you add equation 1 and 2, you have same limit, same denominator. It means you can add the numerator. You'll end up with actually 2I equals to integration of 0 to pi by 2 dx. How come, sir? Please check, you'll have cos power 1000 and sine power 1000 in the numerator. What's the denominator, sir? Cos power 1000, sine power 1000, which will get cancelled, okay? You'll have only dx left. So integrate this, you'll have x from 0 to pi by 2. I get the answer as pi by 2. This is the value of 2i. You're looking for the value of I actually. So it will become pi by 2 into 2. Hence pi by 4 is the answer. Pi by 4, D is the answer. Okay, D pi by 4 is the correct answer. Okay, so this is your property based question. You look at this and you write the answer. I'll show you once more. Please check. So basically I'll tell you what, I'll tell you the short trick for this. Subtract the limit, divide by 2. Pi by 2 minus 0 you do, pi by 2 you're getting, divide by 2. You'll have pi by 4 na? That's your answer. Look at the next question, you'll understand. This problem, sir, 8 minus 2 by 2. How much is that? 6 by 2. How much is that? 3. Option is D, directly. How come, sir? How come, sir? Because if you take this condition, no, like this, please check. Sorry, I took yeah, plus only, na? Correct, plus only, yeah. So if you go about this, no, what you'll have? 8 plus 2 minus x, right? What are you gonna get? 10 minus x, you're going to replace this x by 10 minus x. So whenever you do that, you'll have this as simply x and this as 10 minus x, this as simply, please check, this is the whole root, okay? This will become x again. When you do that, you'll have same numerator, same denominator, they'll cancel, which will lead me to x. X will be under the limit 8 minus 2. If you do the upper limit minus lower limit, you'll have 8 minus 2, okay? This side you'll have 2i like this case, 2i, 8 minus 2 by 2 will become 3 only. So that's how you solve this question number 6. I hope you get it. 2017 it was asked. One of the favorite property of KCET examination, this is what I solved right now for the previous question. Minus 5 to 5 mod of x plus 2. Just check for the critical point. What's the critical point here? When it is becoming equal to 0, it means x is minus 2 is the critical point. So take the modulus for there. From minus 5 to minus 2, you'll have this value basically negative. So apply mod here. Okay, and the other case, when minus 2 to 5 you're going, no problem, just keep it like this, okay, right? So because from here to here it's negative, bacha, okay, the critical point is minus 2, na? So before minus 2 will be negative, after minus 2 will be positive. So we'll take the modulus over here. Please check, you're gonna get over this as x square by 2 plus 2x, from where to where, sir? From minus 5 to minus 2 in the modulus, and for this side you'll have again x square by 2 plus 2x, from where to where? Minus 2 to 5. Let's simplify this. So you'll have over here, modulus is there, of course. We're gonna get 4 by 2, so 2, put upper limit, minus 2 square is 4 by 2 is 2. You get here this minus 4. How come, sir? Minus 2 into 2x will become minus 4 only. Minus for the lower limit, minus 5 square will become 25 by 2. Okay, and I have minus 10. So this is done. Put put this modulus. Put this modulus, sir. Okay, next part for this condition, same way we're gonna proceed with this also. 25 by 2 plus 10, 5 I'm putting here upper limit, minus lower limit you'll put minus 2 square is going to be 4 by 2, which is basically 2 only, and we'll have minus 4 one more time. Please check. So I can simplify this. What I'm getting here, 2 minus 4 is minus 2, and I get plus 10, so 8, right? 8 minus 12.5, no? How much I have? 2 minus 4 is minus 2, then I have plus 10 over here. Please check. So I'll get plus 8 minus 12.5, plus 8 minus 12.5. okay, this is in the modulus. All right, another case, please check. I have again 12.5, and this part is going to be 2 minus 4 is minus 2, then I get here minus sign one more time, so get plus 2. Please check here, 2 minus 4 is minus 2, this is 2 only, na? So minus 2 and minus will become plus 2, 10 plus 2 will be 12, we'll have plus 12. There is no modulus over there, 1 second, there is no modulus over here, simply the values. So we have 12 on this side, L becomes, please check, minus 4, so 4.5 you'll have on this side, and 12.5 plus 12, please check, it'll become 16, so 17 by plus 12, answer is going to be 29 square units. 29 is the answer. Please check. B is the correct option for the question number 7. Question number 8 now. Simple question 7. Okay, just know the critical point. Question number 8 now, you can see the, okay, we have formula for cos 2x. We'll apply that. Okay, so we'll apply that and we'll get cos 2x as 2 cos square x minus 1. And same way you'll have minus sign over here. For cos 2 theta, you'll have 2 cos square theta minus 1. Please check. So I'm getting over here same thing, cos x minus cos theta. Of course we have dx over here. Please check. So we'll have minus 1 plus 1, so they'll cancel. How come plus 1, sir? Because bacha, this is minus into minus, na? So become plus 1 only, will cancel. So what I have left now, I can take 2 common, I get cos square x minus cos square theta upon cos x minus cos theta dx we have. Okay, take this 2 outside. We have a square minus b square upon a minus b. A square minus b square upon a minus b. What is the result? A plus b. Because this is going to be a minus b into a plus b. That will cancel this denominator. You'll have only a plus b left. So right here, cos x plus cos theta, of course, dx. The variable is x over here, not theta. So don't integrate theta also. Only x is the variable. Okay, this is a constant value. So you get 2 outside. Cos will become sin x, and this will become, so simply nothing is there, only dx is there, so x cos theta. Please don't make this mistake. Cos theta is not the integration variable, it's a constant. So keep it as it is, integrate dx only for this part. Second integration is only dx, answer is x. 2 sin x plus x cos. Please check. 8th answer is A. 8th answer is A. Moving on to question number 9 now. It's a PYQ again, 2017. So again, x plus 3 e power x plus 4 square. Again another property based upon exponential function. Very useful. You can see again repeating in 2017 paper. So we can see here x power 4 is there, means I'll try to make x power 4 in the numerator. So keep e power x outside and make here x plus 4 minus 1 upon x plus 4 the whole square. Please check. This completes your actually question itself. Right here, separate this bracket, you'll have 1 upon x plus 4. Because there's x plus 4 over here, there's a whole square over here. That's why 1 upon x plus 4. Another part will be minus 1 upon x plus 4 the whole square. Of course, there's a dx. Check this out. This is going to be your, check it out, fx, and this is going to be your f dash of x. How come so? X plus 4 power minus 1 is there, no? If you differentiate, you'll have minus 1 times of x plus 4 power minus 1 minus 1. So minus 2 comes here in the denominator, becomes square. Minus 1 is as the coefficient, okay? So answer will be simply ex fx plus c. Hence ex times of, what is it going to be? Ex times of this x plus 4 in the denominator plus c. Option like this. Option A looks good. Please check. Option A is correct. Okay, question number 9 is done. Question number 10 now. So I hope you can see this. Questions are there from PYQs. I have also taken some questions which is not a PYQ. That will come at the end. Right now, let's solve these questions. Very important questions. You can see mix of all. Simple problems are also there. Difficult questions are also there. So when you see the problems in the examination, no, not all the questions from integration will be very difficult. Not every question in integration will be very difficult, sir. Some will be very solvable as well. So if you have practiced enough, you'll get those answers right. Okay. Question number 10 now. So 0 to pi by 2, 1 upon a square sin square x plus b square cos square x. Good question. Let's solve it. No property I can see over here right now. Divide by cos square. That will make tan. Yeah. Divide by cos square. So keep this limit as it is. Okay. Or why not? Okay. We'll keep it as it is only. So we'll have over here sec square x upon. Please check. I have a square tan square x plus b square. So what I've done, bacha, here, I hope you can see that now. So I've divided both numerator and denominator by cos square x. So I get here tan, I get here this cos square get cancelled, and 1 by cos square will become sec square in the numerator. I have 1 no in the numerator, divided by cos square, it will become sec square. Okay. Now I'll forget about the limits for now. I'll solve the question. Okay. Check this out. So I can take this tan x as t. So I have dx sec square x equals to dt. Dx sec square x equals to dt. Differentiate it. So you'll have, please check, you have over here dt upon a square t square plus b square. From here you can take a square common. You'll have dt upon t square plus b square by a square, and of course a square is common outside. So what I've done over here, a square is taken outside. I don't have a square over here, it means I have to divide by the same value so that it can cancel if you multiply it back. Okay. So you have a square over here. Please check. Alright. Now I'm going to again integrate this. This is a formula for this part, right? 1 by a square is outside. I have the formula as 1 by a. This value which is 1 by a actually. What is that going to be? B by a the whole square, right? B by a the whole square is the a value. So we have 1 by that, and we have tan inverse, of course, of t by a. Okay, so we have t by same thing. Please check. Okay, t by a. All right. So we get, please check, we get a and a cancel. I'm having here 1 by ab. This a and a square will cancel, right? This is a is in the denominators. Please check, basically division. This is multiplication, right? So gets cancelled. I have over here, please check, tan inverse of, I switch back. A will go up, so I have a by b. T value is bacha tan, right? So a by b tan x. Now I'll put the limits. What is that? 0 to pi by 2. When you put here pi by 2, you're going to get this value as infinity. Okay, so you'll have 1 by AB. Please check tan inverse of infinity. How come, sir? Tan pi by 2 is infinity. No, multiply anything to that, it will be infinity only. So we have tan inverse of infinity minus, when you put 0, tan 0 is 0. This whole thing is 0. Tan inverse of 0 is, sir, 1 more time 0. So answer will become, please check, 1 by AB. This value will be, sir, bacha, what? Pi by 2. I get the answer as pi by 2 AB. How come? Please check. Tan pi by 2 is infinity, right? So tan inverse of infinity will be pi by 2 only, right? So pi by 2 AB is your correct answer. Have a look. Answer will be C. I hope this is clear. Okay, so I can move on to question number 11 now. Let's start. So question number 11, have a look. Okay, this question, again, there's a trick for it. You know, there's a part of particular functions. Okay, so you know, for this numerator part, you have x plus 1 by 2. Basically, the formula is x by 2, the same root plus log will come, of course. Sorry, a square by 2, right? You have a square by 2 over here. A square by 2 log of that function. Okay, I'll write again. So a square by 2, then log part will come. Okay, so look at this very carefully. Again, same root will be there. So wherever you have this root, what is this going to be? Can you make the whole square over here? You have x square plus 2x. What is missing? Plus 1. What is it going to be then? 5 will split as 4 plus 1. This will become, sir, x plus 1 the whole square plus 2. So will become 4 will become 2 square. Okay, so this value will be your answer. So x will be replaced by this. You'll have x plus 1 by 2. Okay, same root will repeat, this root, same root. Okay, and same way over here you'll have, please check, 4 by 2. No, a square is 4, right? So 4 by 2 will be 2 log, and inside also you'll have same root condition. Okay, please check which option is like. So we have only one option, B, x plus 1 by 2, same root repeats, plus 2 log, and same root over here. It means clearly option B is correct. So if you know the formula exactly, if you can do one step to, you know, make this perfect a square for the first part, and from there you can actually relate to the formula and get the answer directly. 1 minute it will take. Okay, very difficult question. If you solve it will take a lot of time. But if you know the formula, not even 1 minute. Okay, 30 seconds to look at the question and get the answer. Pick one and move on. Okay, 11th is done. Question number 12 now. So this is a trick for your question number 11. I've given you a trick in the sessions as well. Okay, so which question can be solved from which steps? I know you can't solve every step to get the answer. Quickly you can, you know, analyze the problem and get the result if possible. Okay, not in all the questions, but if possible. Please check over here. This is a good question. 12th is a very good question. Please check. So right here, I equals to, what you'll have, minus pi by 2 to pi by 2. We'll write the same thing over here. Dx upon e power sine x plus 1. This is my equation number 1. Okay, next what I'm going to do, add this, right? Pi by 2 minus pi by 2, then minus x. What I have? 0 minus x, basically minus x. Replace x by minus x. What are you going to get? Have a look. You'll have I value one more time as minus pi by 2, limit does not change, remember, and you have dx upon e power sine of minus x. It will become minus sine x only plus 1. Right? Sine of minus x is what, bacha? Minus sine x. Okay. Now take this, basically multiply both up and down by e power sine x. So you'll have a look. I'm trying to simplify so that I get the same denominator as this. This is the value I. I'm multiplying both sides, so I have e power sine x. Numerator is multiplied. Of course, dx will be there, and denominator, this will become, bacha, 1. E power minus x into e power x will be e power minus x plus x. So e power 0 will become 1. I'm multiplying e power x. Basically, I'm multiplying here e power sine x upon e power sine x. Okay. So I get here e power sine x dx in the numerator. I get 1, and I get for 1. For this part, I get the same thing. Plus e power sine x. Make this as equation number 2. Equation number 2. Now you add these two. Add these two. What do you have? Please check. So you have over here equation 1 and 2, if you are adding, you will get 2i in the left hand side, I plus I, so 2i. Please check, denominator is same, so you can add the numerator in the same limits. Minus pi by 2 2 pi by 2, you have what bacha? E power sin x over here, you have nothing, means 1 over there. So you get e power sin x plus 1, of course dx outside, and divided by e power sin x plus 1. Cancel, you have answer as simply x after integration from where to where? Minus pi by 2 to pi by 2. Answer will be pi by 2 minus of minus pi by 2. Okay, so pi by, basically pi by 2 plus pi by 2. How much is that? Simply pi. Okay, simply pi. This is your 2i, right? So I get I value as pi by 2. I value as pi by 2. Excellent question. Usually what happens is we can apply the property directly. In this part you have to apply some, some steps you have to solve. You have to solve till this point. Once you solve this, what is going to be? Please check here. This and this will become same, right? Okay. Our denominator is same after this step. Subtract the limits, divide by 2. You'll have pi by 2 minus pi by 2. What is the difference? Pi divided by 2. Answer will be pi by 2. Option C is correct. Question number 12 is done. Now moving on to question number 13 now. 13, sir. Same property, right? Please check. I have cot 7 tan 7. What is going to be the property, bacha? Pi by 2 plus 0 minus x. How much is that? Pi by 2 minus x. Replace x by this value. You'll have tan. At this tan will become, sir, cot, and cot will become tan. Hence what I can say? Basically I can say the answer will be 2i equals to pi by 2 minus 0. Hence I equal to pi by 2 into 2. So I have I equals to pi by 4. Pi by 4. Option A is correct. See, again a PYQ in 2017. Okay, so moving on to question number 14 now. Please check. Root of cosec x minus sin x dx. Good question. Please check. But not difficult at all. Right here 1 by sine for this part minus sin x, this whole thing in the root, of course dx is there. Right here I get 1 minus sin square x upon sin x in the root. Okay, so I'm going to have here cos square will become cos x because root is there upon root sin x, integration dx. From here you take sin x as t, derivative will be cos x dx equals to dt. Apply the substitution, bacha. You have dt upon root t. What is the answer going to be? You'll have answer as root t by 1 by 2 plus c. So 2 root t plus c. 2 root sin x plus c. 2 root sin x plus c. Option is A. Please check. Got it? Okay. I have done all the steps, but you can get the answer directly from here also. If you can write the step, you can see a substitution will be there for sin x as t, and directly answer will be option A. From here you can get the step as the answer as A. But first 2 steps you have to write. Okay. If you can do it this also in your mind, good for you. 14th is done. 15th now. 1 upon. Okay. All right. So to simplify over here, I have 1 extra. Let's remove this one. So right here 1 upon dx, write 1 as sin square plus cos square. So I'll have sin square plus cos square will become, bacha, 4 sin square, no? Right here 4 sin square x. How come, sir? I already have 3, right? I'm gonna get 1 over here, 1 as sin square x plus cos square x, right? So I'll have this 4 sin square x plus 9 cos square x. Okay, I can see there's a formula forming over here, but divide by cos square for that. So I get 1 by cos square will become sec square x dx, and over here I'll have 4 tan square x plus 9. Divide by 4, now take basically 4 common, you'll have 1 by 4 outside, and of course you have sec square x dx. Tan square is free now, and you have over here 9 by 4. I'm going to use substitution now. Substitution will be t equals to tan x. So what do you have? dt as sec square x dx. Sec square x dx. Okay. The question will become, have a look, 1 by 4 is of course outside. Integration of dt upon t square plus 9 by 4 will be 3 by 2 the whole square. Formula is there. I write it like this. 1 by 4 is outside only. 1 by a. So 1 by 3 by 2 tan inverse of t. Correct now? Tan inverse of t. Okay. Sorry, 3 by 2. Excuse me. T by a, right? Not just t. T by a. T by 3 by 2. T by 3 by 2. So what I get? This is cancelled. I have over here 1 by 3 into 2. So I get 1 by 6 tan inverse of t value is tan only, right? So 2 tan, because this 2 will go up, right? So 2 tan x upon 3. Please check. That's your answer. Of course, plus c will be there now. 1 by 6. Okay, option A looks right. Option A is correct. Please check. Option A is correct. Okay. So simple problem only. 15th is done. Question number 16 now. So what we have in 16, sir? We have this big integration asked in 2023. Have a look. How can I solve it? Very simple. These two are very simple. We have to only take care of this part. I can do this by parts. So I'll have eyelet applied over here. Okay. But limits is there. So we have to be careful with the limits. Okay. Please check. So integrate over here. We'll have this value. I can write directly, no? I don't have to write this integration once more time. Chali, let's start. I'll have x power 4 by 4 plus x cube, because x cube by 3 and 3 will cancel, right? I'll have this as x cube by 3 and this 3 will cancel. So x cube by 3, then I have over here 3x square by 2 plus 3x. This is just polynomials. I'll keep the limits for this one separate, minus 2 to 0. Okay, and then I'll have a plus sign. Integrate bacha now. By parts will be there. So for this part, please check. This is my function 1, function 2. ATE. Algebra has the preference. So keep x plus 1 as it is. This time integrate cos. You'll have sine x plus 1. Correct now? Sine x plus 1. Please check. And for this condition, what you have, bacha? Sine, the coefficient of x is 1 only. So we don't have to divide anything over here with sine. If you had sine 2x, sine 3x, sine 4x plus 1, you divide by 2. But we have only x, so we don't have to divide by 1. And limit for this bacha will be from where to where? Minus 2 to 0. This is only one part. Other part is also there. There is a minus 5 sign for that. I'm talking about the by parts. Integration of derivative of this first function. You'll have 1 over here. Please check. This is my first function, right? Okay. So 1 over there for the derivative. And this will again turn out to be sine of x plus 1 from where to where? From minus 2 to 0. Of course, there is a dx over here. Okay. Now please check. Step 1 over here, step 2 now. For 0, it will all be 0, right? This is all going to be 0 for upper limit. Now for lower limit, put a bracket. Minus 2 is there. So I get minus 2 power 4. 16 by 4. So simply 4. Minus 2 power 4 is 16. By 4 is simply 4. I get minus 8. 2q is going to be 8. There's a minus sign, so minus 8. Okay. And I have over here 3 is into minus 2 square. So 4. Basically 3 into 4 by is 2 is going to be 12 by 2. So plus 6, and have minus 6 over here. Close the bracket. Okay, and this part, have a look. Put this as 0. You're gonna get 1 times of sine 1 times of sine 1, putting x as 0. Okay, 1 times of sine 1. Now for the lower limit, there's a minus sign. Minus 2 plus 1 will be minus 1. Okay, and you have sine of minus 2 plus 1. It will become sine of minus 1. Have a look. Minus 2 plus 1 is minus 1, no? Sine of minus 1. We know sine of minus 1 is nothing but minus sine 1. And you have a minus sign. It means this will become, bacha, positive, right? This will be positive. Okay, chali. Now the last one. This is a minus sign. Integral of sine is going to be minus cos. I had a minus sign over here. Integration of sine is going to be minus cos. So that will make plus. Right here, plus cos of x plus 1 from where to where? Minus 2 to, minus 2 to 0. Okay. Now check this out. I have 6 and 6 cancelled. I get 4 minus 8 is minus 4. Okay. There's a minus sign over here. It means plus 4. Please check. 4 minus 8 is minus 4. There's a minus sign over here. So plus 4. Plus 4 is there. Now have a look. I have sine 1 and sine 1. So cancelled, sir. Correct, na? It had minus sign, minus over here. Cancelled over that side. Sine and sine, negative plus positive will can again get cancelled. Okay. This is 0. What about this, bacha? You will have for this case, please check. you have for this case cos of 0. If you put, you get cos of 1. Cos of 1, there's a minus sign. Cos of minus 2 plus 1. So I get cos of minus 1. Please close this. My last step actually. I get 4 plus 0 is nothing. Okay. Have a look. Cos of 1. And cos of minus 1 is how much, sir? Cos of 1 only, right? Cos of minus x is simply cos x. So I get one more time cos of 1. Cancel, cancel. What is the answer going to be? Answer is simply 4. So option A is correct. 16th one, option A is correct. So in this question, after writing this part, okay, even after writing this part, you can see answer will be, this is also going to be cancelled, this is also going to be cancelled. Okay, answer is going to be simply 4, this constant. Okay, so first step and second step is good enough to get the answer as 4. 16 is done. 17 now. Okay, question number 17 now. Again, a very simple question. If you can make this in the form of your perfect square, you will have x square already. You have minus 2x. You need plus 1 and separate this 4. Write 5 as 1 plus 4. You get x minus 1 the whole square plus 2 square in the root. Formula you know. Same thing is there. X minus 1 by 2. Same root will repeat plus. Okay. You'll have a square by 2. So 2 square by 2 will become again 2. You'll have log and same root will repeat. Have a look. So you have x minus 1 by 2. You have 3 places. Okay. This cannot be there, bacha. Okay. Yes. These 2 can be true. Option A is the gone. Right now option A is gone because you can't have this. Please check. These 2 roots are different. So option A is gone. Option B and C is the right one. Okay. We have x minus 1, sir. We don't have x plus 1. It means B is also gone. We have answer as option C. Please check. We have x minus 1, na? So you have log of x minus 1 plus. You have x plus 1. It means not possible. Answer is going to be, please check, C only. Otherwise you can check from here also. The root is different. Okay. So option C is correct. 17th is C. 18th now. Tricks are there to solve the questions. 18th now. The area of the region bounded by the line. Okay. Please check. Okay, x plus 1, right? When x is 0, y is 1. When y is 0, minus 1. So please check. We have this only, na? X is 0, y is 1. When y is 0, x is minus 1. Okay. From where to where, sir? From 3 to 5. Or positive only. No problem. 3 to 5. So positive only. So integrate directly. X plus 1 integration from 3 to 5. Please cross check for the negative region. Okay. If you have negative region, then make the bifurcation and make the negative region with the modulus to get the result positive. Area is going to be positive. Okay. So you'll have x square by 2 plus x from where to where? From 3 to 5. You get, please check, 25. You have 25 by 2 and you have plus 5 minus sign, 9 by 2 plus 3. So I'll have the answer over here, 25 by 2 plus 5 minus 9 by 2 minus 3. I get 5 minus 3 as, please check, simply 2, and 25 minus 9, so 16 by 2 plus 2. I get 8 plus 2 as 10. Option B is correct. Correct now. 25 minus 9 is 16, so 16 by 2 is 8, and 5 minus 3 is 2, so 8 plus 2 will be 10. Answer is B. 18th is done. 19th now. Okay. The area bounded by the line y equal to x-axis and the ordinate minus 1 to 2. Please check. Curve is y equal to x, right? So write this curve. Y equal to x is this curve. From where to where? From minus 1 to 2. So minus 1 to 2. Please check. So I have to take this area separate and then apply a mod. So apply this. We have x integration from minus 1 to 0 with dx. Apply modulus over here, and of course you'll have same integration x with 0 to 2. No problem on this side because it's already positive, right? This is positive, this is negative now. So you have the answer as x square by 2 from where to where? From minus 1 to 0, and you have of course modulus over here plus x square by 2 from where to where? From 0 to 2. For 0 you're gonna get 0 only. This is a minus sign, so lower limit will be, please check, 1 by 2 mod is here, and you have for this 2 square is going to be 4 by 2 is going to be simply 2 minus 0. For the lower limit is going to be 0 only, na? So you have 1 by 2 plus 2, how much is that? 5 by 2 or 2.5. Correct. Option B is correct. 19th, option B is correct. 2 on this side and plus 1 by 2. Answer will be 2.5 or 5 by 2. Question number 20 now. Question number 20 now. The area of the region bounded by y-axis, y equal to cos x and y equal to sin x. Y equal to cos x and y equal to sin x. Draw the graph. So we have, sir, cos x now. So like this, we have cos x. And for sin x, please check. For sin x, we have something like this. Okay. Something like this. It will not be actually right. I have taken the graph incorrect. I'll change that. It will be up, no? Okay. So it will be something like this actually. Okay. Now, for this case, please check. You have looking for, this is, sir, cos x. This is, sir, sin x. Okay. And this is, sir, y-axis. Correct, na? So the region is going to be this only, right? This is my region. So basically, what is this point called, bacha? When is sin and cos equal for the first time? At pi by 4. At pi by 4, cos pi by 4 is 1 by root 2, sin pi by 4 is 1 by root 2. It means they are equal. So basically, integrate cos x minus sin x from where to where? From 0 to pi by 4 with dx only. Okay. Do we need modulus sign? Of course not. It is above the x-axis, means positive only, right? So integrate this, bacha. We have this as the area. So area will become, cos will be simply sin, and sin will become, bacha, plus cos, sorry, minus cos will become plus cos. From where to where? Please check. From 0 to pi by 4. I hope you understand this. Correct, now? Cos will become sin will become minus cos. You have a minus sign, it becomes plus. Apply the limits now. You get 1 by root 2. For sin, again you get 1 by root 2 for cos. This is your upper limit, minus sin 0 is 0 and cos 0 is 1. So you have 1 by root 2 plus 1 by root 2 is going to be 2 by root 2 minus 1. How much is that? Simply root 2 minus 1. You can cancel this over this, no? You can cancel this, it will become root 2 minus 1. So option A is correct. Please check. Option A is correct. 21 now. The area of the region bounded by the curve y square equals to 8x and the line y equal to 2x. Okay. Curve is this and line is this. Okay. Alright. Now points we need. One point is just 0, 0. Origin is there, of course. Other points, we need this point, right? So this point, if you look at very carefully, you will have, put this value over there. You're going to get 2x the square equals to 8x. So I get 4x square equals to 8x. It means x has to be equal to 2, right? X is 0 and x is 2. Please check from here. X is 0 and x is 2. When you put x as 0, it will become both sides equal. When you put x as 2, it will become 4 into 4. So 16. 8 into 2 will be again 16. Okay. So this point is 2 actually. This point is 2 comma, what is it? 2 comma 4. 2 comma 4 is the other point. So basically integrate to get the area. Integrate, the function is root 8x from where to where? From 0 to 2, and minus of course is there, minus 2x also is there from 0 to 2. Okay. Integrate this part. Alright. Basically below this curve parabola and above this line. Okay, straight line. That's why difference is there. This minus this. Okay. So have a look. What I'm getting, I can separate this. I'll get this as root 8 is a constant. I get root x integration as x power 3 by 2 upon 3 by 2. From where to where, bacha? From 0 to 2. Okay. And I have this as minus, please check, simply x square from 0 to 2. Correct, na? Because x square by 2 will be there and 2 and 2 will be cancelled. So I have only x square left. Put the values now. I get root 8 is there. 2 power 3 by 2 upon 3 by 2. For 0 will be 0 only, right? Minus 0. And for this again you will have 2 square. So 4. Again for 0 will be 0 only, right? So you get, this is root 8, right? So you have root 8 into root 8 upon 3 by 2 minus 4. Okay. This will become, sir, 8 into 2 by 3 minus 4. Correct, na? This 2 will go up. Root 8 into root 8 is nothing but 8. So I have 16 by 3 minus 4. LCM will be 3 only. We have 16 minus 12. So I have 4 by 3. Please check. Correct, right? 16 minus 3 into 4 is 12. So 4 by 3. Option A is right. Please have a look at question number 21. Option A is correct. Okay. 22 now. The area of the region bounded by the line y equal to 2x plus 1. Okay. When x is 0, y is 1. When y is 0, x is minus 1 by 2. This is the curve, right? Doesn't look like a straight line. I'll make it better. Okay. So I'll make it better. Just give me 1 second. Something like this. Okay. And now we have x equals to minus 1 to 1. So minus 1 over here, 1 over here, and I have a point over here as minus 1 by 2. Minus 1 by 2. So basically, integrate this function 2x plus 1 from minus 1 to minus 1 by 2. Okay. Of course, with dx inside the modulus, because of this negative part. This is negative, right? This is negative, this is positive. Okay. So I have to integrate this negative part, okay, and put a modulus to get the area as positive, and plus. Same way from minus 1 by 2 to what do you have? Plus 1. Integrate, same thing, 2x plus 1 dx. Okay. So when you do that, what you'll have? Please check. You'll have x square plus x. From where to where? From minus 1 to minus 1 by 2 in the modulus, of course. Same way you have over here, x square plus 1 minus 1 by 2 to 1. Correct now? Please check. It will become x square by 2. 2 and 2 will cancel. So x square plus, sorry, I wrote 1 now. It will become x actually. X square plus x. 1 will become x, right? Integration of 1 is x. Okay. Now this is my area. So please check now. So I have to write this a as, substitute the limits. So I get a value of this as modulus is there, of course. We get minus 1 by 2 square, so 1 by 4. We get again minus 1 by 2. And over here with 1 I get, this is a lower limit, so minus sign. I get again 1 minus 1, right? Minus 1 square is going to be minus, basically plus 1. We have x as minus 1, so minus 1. And this is done, right? For the next part you have same thing. Please check. You will have a bracket over here. 1 square is 1. 1 is, again x is 1, so 1. Lower limit is minus. Please check. We get lower limit as 1 by 2 square, so 1 by 4. And we have simply minus 1 by 2. So we have again bracket over here. Please check. This is cancelled, right? I have 1 by 4 minus 1 by 2. It becomes so minus 1 by 4 in the modulus. Of course, this is a plus sign over here. Bracket is there. 1 plus 1 is 2. I get here minus sign of minus 1 by 4. Please check. Correct now? 1 by 4 minus 1 by 2 is minus 1 by 4. Okay. So I'm getting here 1 by 4 plus 2 plus 1 by 4, because there is a minus of minus, no? So plus, I get 1 by 4, and 1 by 4 is nothing but 1 by 2 plus 2. How much is that? 2.5 or 5 by 2? 2.5 or 5 by 2. Option is B. Please check. 22 option is B. Okay. Simple problem. Very simple. Just if you know your values, if you know how to draw the graph, this part, which is negative, which is positive, question becomes very, very simple. Okay. 23 now. Question number 23 now. The area of the region bounded by y equal to this. Very simple, sir. It's a circle, right? So right here y square equals to 16 minus x square. Move this on this side, you get x square plus y square equals to 16. It means your value of radius is nothing but 4. The area is nothing but pi r square, right? Okay. So pi into 16, right? Okay. What are they asking? And x-axis only. Okay. They're asking, this is the circle, right? Center is the origin. Sorry. Origin and center is same. Okay. They're asking only this part with the x-axis, right? So we get only positive side, so half of this. So you have this answer as 8 pi. 8 pi. Option A is correct. Option A is correct. Half of the 16 pi will be 8 pi, right? So option A is correct. 24 now. For 24 we have, if the area of the ellipse is this, you know the formula for area of ellipse, right? It will become pi AB, no? It will be equal to 20 pi. They have given that already to us. Okay. So I get this as, please check. I have pi as it is. A is going to be 5 and B is as it is. I get 20 pi. Pi cancel. 5 4s are cancelled. I'm getting B as 4. So B as 4. Sorry, lambda is there, na? So B as 4. Plus minus 4 is correct. Please check. 5 into 4 is 20, correct. Why plus minus 4 bacha? Because actually if you check here, you can take 25 root as plus minus 5, no, that's why. This will be sir plus minus 5 here, so you'll have plus minus 4. This value will be actually plus minus 5, so that's why it will also be plus minus 4. This is square, no, that's why. So lambda will be plus minus 4. I have taken here as b, right? So actually it's given as lambda. So just change the variable. This is lambda they have given, okay? So let's change that variable. We have lambda, lambda, lambda. Got it? So that's answer. Option A is correct. 25 now. If the area of region bounded by the curve y equal to tan x and the x-axis and the line this. Okay, so positive only, right? Okay, so we have integration of, please check, tan x from where to where? From 0, of course, and because they're saying x-axis, right? And then pi by 3. Answer will be log sec x. Remember, integration of this is log sec x. From where to where? From 0 to pi by 3. Please check. So you have this value as log sec of pi by 3. How much is that? 2. Cos pi by 3 is 1 by 2, so sec will become 2 only. So log 2 minus sec 0 is nothing but 1, because cos 0 is 1, sec is also 1, so log of 1. This will become 0. I have over here answer as log 2. Log 1 is 0, right? So log 2 is the answer. Option C is correct. Option C is correct. Integration of tan is log sec x, okay, or minus log cos x, your choice. 25 done. 26 now. Area of the region bounded by the curve y equal to cos x, x0, x equals to pi, cos x, right? Please check. Cos x starts from here, goes all the way till this point, right? Okay, I have both plus and minus sign. So basically I'm going to do what? Integrate till this part. It's symmetric, right? So I'll just integrate cos x only. From where to where? From 0 to pi by 2 and multiply this with 2. That's your answer. Because if you do from 0 to pi, you get answer as 0. Plus and minus, they'll add, no? So you have to take this part and multiply that by 2. So cos x integration bacha will be sin x, na? From 0 to pi by 2. 2 is outside. You get this as 2 times of sin pi by 2 is 1 minus 0. Answer will be simply 2. Sin pi by 2 is 1. Sin 0 is 0. 2 into 1 will be 2. Answer is A. Answer is A. Please check. 26 is done. 27 now. We have, okay, this. As I said, I've taken some questions which is not a PYQ but very good question. Let's see. So can we solve this? Of course we can solve this. They're asking the value of fx, right? Let's do one thing. Take this t equals to minus 4x cube. From here find the value of x cube once. X cube will become minus t by 4. Minus t by 4. Okay. And derivative will take, we get dt equals to, please check, minus 12 x square dx. Minus 12 x square dx. How come, sir? Because 4 into 3, right? So minus 12. From here I get minus dt by 12 equals to x square dx. Check the integration now. What we have, integral, write x power 5 as simply x cube and e power t, okay, x cube, and write x square dx together. Please check now. X cube is given as minus t by 4. I have taken this out. So minus t by 4. E power t as it is. X square dx is how much, sir? Minus dt by 12. Okay. You can see here I'm getting this 4 and 12, right? So I'll have that value as 48. So 1 by 48. Minus into minus will become plus only, na? So plus integration of t is left, et and dt is there. T et dt. T et dt. Integrate this. We have the standard formula for this. We have 1 by 48. Excuse me, 1 by 48. We know we can use by parts, so we'll have basically TET minus ET, okay? TET minus ET actually. And have a look, I can take 1 by 48. E power t common, you have t minus 1. So we have the same thing. This is nothing but t. So this is 1 by 48. This is nothing but e power t. This value is fx. So basically fx is nothing but, fx is, sir, please check, t minus 1. What is the value of t, bacha? Value of t is minus 4x cube. Minus 4x cube minus 1. minus 4x cube minus 1. Compare here. This t minus 1 is same as fx, right? Of course, there's a plus c over here. So t minus 1 is nothing but fx. So fx will be t minus 1. T is nothing but minus 4x cube. Answer will be minus 4x cube minus 1. Option B is correct. 28 now. 27th is done. Not difficult. Good level question. Okay. 27 is done. 28 now. Find integration of a minus x upon x in the whole root. Okay. How do you solve it, sir? Of course, you have to apply substitution. Okay. So take here. Please check. Take here x as a sine square theta. Now check this out. You'll have this integration as root of a minus a sine square theta upon a sine square theta d theta, right? What we have, take a common, so you get this a and a cancelled, right? Okay, a and a cancelled, right? Okay, this is incorrect, so this is incorrect. I made a mistake. I'll keep this as dx right now. I'll change it to d theta later. Okay, this is a dx only, bacha. I'll change this dx to d theta later. Okay, please check. If you want, I can show it over here. So you have this x as a sine square theta, na? So you'll have dx as, please check, a into 2 into sine theta into cos theta d theta. Correct, na? Please check. A into 2, because 2 will come in front, so sine will remain as it is. The sine differentiation is cos and the theta will come. Okay, so 2a sine theta cos theta we have. Check this out. I can take this a and a cancel, right? I have 1 minus sine square in the numerator, basically going to be cos square theta in the root, and of course we have denominator as simply sine theta, and of the, this will become, sir, 2a sine theta cos theta. 2a sine theta cos theta. Have a look. So I'm getting here this sine and this sine cancel. So I have this become 2a integration. I have cos here and cos here. So cos square theta. This is d theta over here. D theta. Correct now. Please check. 2a is here. Okay. And we have cos square root will become cos into cos become cos square. I can write the formula we have for this 2a integration. For this I'll have cos square, right? So by 2, 1 plus cos of 2 theta d theta, right? Formula is there for cos 2 theta. Okay, this 2 and 2 is cancelled. I have here a as it is. Integrate, bacha, 1. So I get theta over here and plus, please check, I get integration of cos, so will be minus sine 2 theta divided by 2. Okay, of course, like this you'll have plus AC also. Now continue on this side. You have a theta, right? Please check from here. Okay, check from here. I have x by a as sine square theta. It means root of x by a will become, what is it going to be? It's going to be, sir, please check, sine theta. So you'll have theta value as sine inverse of root x by a. Root x by a. Okay. So if you simplify this, you'll have this value from here. A is there, of course, and you have, on this case, theta is there, na? Theta will become sine inverse of root x by a. Okay. And then of course you'll multiply this also. So you'll have minus a by 2. Write sine theta as 2 sine theta cos theta plus c. You can get 2 and 2 cancel. Okay, so you have a sine inverse of root x by a minus a sine theta cos theta. Okay, please check your answer directly is option number D. Option D is correct answer. Option D is correct answer. How come, sir? How come D is correct? Please check. So if you have a look over here, we have only one term like this, a sine inverse of root x by a. If you want to solve this, you can solve, no? Sine theta value is how much, sir? Root of x by a. So right here, a will be as it is. You have root of x by a, and cos will become 1 minus sine square. So 1 minus, we have sine square also, x by a. So 1 minus x by a. You get, please check, you get a minus x by a. You have root a over here. So you get here a, please check, x times of, x times of a minus x upon we have a now, cancel. Please check, we have root a and root a. It will become a. Cancel this with a. You get x times of a minus x. X times of a minus x. Formula is a times of sine inverse of x minus a. This will continue, right? Over here and over here. Answer is option D. Please check. 28 is done. 29 now. 28 was a good question. Okay. 29 now. This very simple, bacha. It means in the x you should have multiplied with 2. Then only you can integrate this, no, and get this as bacha, divide by 2. Okay. So we have only one case as such, option D. Why not this? Because if you have c over here, you get cx also, right? If you integrate this, you'll get cx also, but there is no cx over here, simply c. Okay. So constant of integration comes after the integration, not before. Okay, this is before only. After integration, how can it come as it is? No. So please check, option is 29D. 30th now. 30th is the last question of the day. We have from top 30 of AOI and integral. Okay, let's solve this question very quickly. What we have, integral of dx upon sine 2x tan power 9x. Okay, so I can solve this. We have over here, of course dx is there now. I can take this tan in the numerator. I get cot power 9x. Check the denominator, I have sine 2x, no? So I write here 2 sin x cos x, 2 sin x cos x. So I can separate this one of the cot over there. So I get here cot of power 8x into cot. I write this as cos x by sin x, and I have what else in the denominator? 2 sin x cos x. Okay, dx is here. Cos x and cos x cancelled. I have 1 by 2 outside. Integration, please check. Cot power 8 x is there, and denominator I have sine into sine, so cosec square. Cosec, sorry, excuse me, sine square, not cosec, sine square x. Sine square x. What I have? Sine square x dx. Take this in the numerator, what I get? 1 by 2 is there. Integration of cot 8x, and we have this time cosec square x dx. Okay, now we'll have the substitution. Take cot x as t, you get different derivative, this as minus cosec square x dx as dt, hence I'll have this value as minus dt. So integrate this, you'll have minus 1 by 2, and this will be t power 8, right? T power 8, and this will become some minus dt. I've already taken the minus sign outside, it will become simply dt now. Okay, so I have this as 1 by 2 t power 9 by 9, okay, plus c. I have t power minus t power 9 upon 18 plus c. So I have minus t power 9 is cot power 9 upon 18. Option D is correct. Option D is correct. Please check. Question number 30. Option D is correct. Okay, so this completes your session on top 30 MCQ from AOI and integral. I hope you had fun. I hope this is visible. So solve all these questions. You can see there are a lot of questions in all the varieties. Simple also are there, difficult also are there, PYQs also are there. So I've taken a mix of all. So please solve all these questions and let me know how you felt about the session. Again, come back for another session in top 30. Till then, take care of yourself. Keep working hard. Bye-bye.